In this chapter, we will learn about alkanes and cycloalkanes. We will classify hydrocarbons and learn how to name alkanes and cycloalkanes as per the IUPAC nomenclature. We will study the conformations of alkanes like ethane and butane arising on account of rotation around the CC sigma bond. We will learn about different types of strains like torsional and steric strains present in different conformations of alkanes. We will examine the bond angle and other strains in various conformers of cyclopropane, cyclobutane, and cyclopentane. We will learn about ring flipping in cyclohexane and methyl cyclohexane and its consequences. We will study the nomenclature and conformations of the stereoisomers of disubstituted cyclohexanes. Classification of hydrocarbons. Hydrocarbons, that is, compounds containing only carbon and hydrogen, are classified into four major classes based on their structure. They are alkanes, alkenes, alkynes, and arenes, exemplified here by ethane, ethylene, acetylene, and benzene. Alkanes are referred to as saturated hydrocarbons since they do not contain any double or triple bonds. Alkenes contain at least one double bond and alkynes at least one triple bond. Arenes are aromatic hydrocarbons with properties quite different from other hydrocarbons. Alkanes nomenclature. Alkanes have the general formula CnH2n plus 2, where n is an integer. The first 10 straight chain alkanes are given here. The first 4, methane, ethane, propane, and butane, carry the old common names. From pentane, Greek prefixes precede the suffix "-en" to indicate the number of carbons in the chain. Thus, we have pentane, hexane, heptane, octane, nonane, and decane. Constitutional or structural isomerism in alkanes. For the first 3 members of the alkane family, namely methane, ethane, and propane, only one distinct structure can be written. However, for butane, with molecular formula C4H10, 2 distinctly different structures can be written. One is called normal butane or N-butane in common nomenclature, and the other isobutane. In the IUPAC nomenclature, they are called butane and 2-methylpropane respectively. The 2 compounds have the same molecular formula but differ in the order in which their atoms are connected. They are related in the sense that they are constitutional or structural isomers of each other. 2 different compounds that have the same molecular formula but differ in the order in which their atoms are connected are called constitutional isomers or structural isomers. The 2 isomers butane and 2-methylpropane have different physical and chemical properties. Constitutional or structural isomerism in alkanes. With molecular formula C5H12, 3 different structural isomers are possible. They are N-pentane, isopentane, and neopentane in common nomenclature. In IUPAC nomenclature, they are called pentane, 2-methylbutane, and 2,2-dimethylpropane respectively. The number of constitutional isomers increases dramatically as number of carbon atoms increase. With C10H22, 75 isomers are possible. IUPAC, or International Union of Pure and Applied Chemistry nomenclature, is used for naming all classes of organic compounds. For example, in the common nomenclature, the straight chain hexane is named N-hexane. The prefix N indicates that it is a straight chain alkane. In IUPAC nomenclature, it is called just hexane. IUPAC nomenclature of alkanes. The branched chain alkane A, named as 3-methylhexane in IUPAC nomenclature, can be used to illustrate the nomenclature rules. Step 1. Count the number of carbons in the longest principal carbon chain in the molecule and give its IUPAC name. The principal carbon chain has 6 carbons. Its IUPAC name is hexane. Step 2. Name the substituent group that is attached to the principal carbon chain. It is methyl. Step 3. Give a number to each carbon in the primary carbon chain in ascending order in the direction that gives the methyl substituent the lowest number. Since C carries a higher number 4, it is incorrect. So numbering is done from left to right as in B. Step 4. Name the compound. A. Write the main carbon chain's name, that is parent name. The name is hexane. B. Attach the substituent group's name methyl to the parent name hexane. We get methylhexane. C. Precede this with the number of the carbon atom having the methyl group. The number is 3. Separate the number from the name methylhexane by a hyphen. The IUPAC name for compound A is written as 3-methylhexane. Naming alkyl substituents and identifying primary, secondary, and tertiary carbons. Alkyl groups are derived from the corresponding alkanes. For example, methyl from methane, ethyl from ethane, etc. Branched alkyl groups can be indicated either by their common name or by their IUPAC name. Some examples are given below. Common name ethyl, IUPAC name ethyl. Common name isopropyl, IUPAC name 1-methyl ethyl. Common name isobutyl, IUPAC name 2-methyl propyl. Common name secondary butyl, IUPAC name 1-methyl propyl. Common name tertiary butyl or T-butyl. IUPAC name 1,1-dimethyl ethyl. Carbon atoms are classified according to the degree of substitution on that carbon by other carbon atoms. A primary carbon is a carbon that is attached to one other carbon. The hydrogens that are attached to primary carbon are primary hydrogens. A secondary carbon is a carbon that is attached to two other carbons. A tertiary carbon is a carbon that is attached to three other carbons. A quaternary carbon is a carbon that is attached to four other carbons. IUPAC, or International Union of Pure and Applied Chemistry Nomenclature of Alkanes. As per IUPAC rules, the substituted alkane 1 is called 3-methylpentane. When more than one substituent of the same type is present, replicating prefixes di, tri, etc. are used to indicate the number of substituents present. Example, isomer 2 is called 2,3-dimethylbutane and 3 is called 2,2-dimethylbutane. IUPAC rules in nomenclature. When more than one type of substituent is present, the substituents are listed in the alphabetical order. Example, 4 is named 5-ethyl 2-methyl-octane. Replication prefixes such as di, tri, etc. are ignored when alphabetizing. Example, 5 is named 4-ethyl 2,4-dimethyl-hexane. In naming the alkane 6, numbering is done from right to left. Only in this order, both the first substituent and the second substituent will have the lowest numbers possible. The compound is named 2,2,5-trimethylhexane and not 2,5,5-trimethylhexane. In multi-substituted alkane chains, counting from either direction enable us to determine where the first difference occurs and apply the rules accordingly. Nomenclature of cycloalkanes. Monosubstituted cycloalkanes are simply named depending on the number of carbons in the ring and the substituent group. For example, one will be named methylcyclopentane. If there are more than one substituent on the ring, their positions are specified by numbering the carbon atoms of the ring in the direction that gives the lowest number to the substituent at the first point of difference. 2 is named 3-ethyl 1,1-dimethyl cyclohexane. In multi-substituted systems, if numbering in either direction does not make any difference, then the numbering is done in alphabetical priority. 3 is named 1-ethyl 2-methyl cyclohexane. Nomenclature of cycloalkanes. Halogens and alkyl groups have equal priority in numbering. 4 is named 1-bromo 2-methyl cyclobutane and not 2-bromo 1-methyl cyclobutane. When the ring contains fewer carbons than the alkyl group attached to it, the ring is treated as the substituent on the alkane chain. Thus, 5 is named 1-cyclopropyl butane.